time for another DraftPhysics.com, debatephysics.com also, video presentation. Alright, so, I mean, these arguments are so simple, and the thing is these people comment, alright, and what you ought to do is try to find one person, okay, I mean, it is possible, you know, I've seen you people draw, like Falwell and different people, they can actually make a video, and you ought to just write a script for them, and then they could draw a picture of it and show us how your drawing is different than my drawing, and then you could explain how your theory works. But you never do any of that. And that would be a simple solution to this kind of stalemate of you just redundantly saying the same crap over and over and over again. I can't do anything about the commenters, right? I mean, yeah, there's no winning here. If you don't respond, they claim, oh, look, I defeated your argument. And otherwise, you're just stuck because they just keep saying the same crap. Okay, I keep countering it, and they ignore the counter argument, and that's it. So there's not much you can do. I can only do my part, as I've said so many times before. If you're unreasonable, belligerent, asshole, idiot motherfuckers, I can't do a damn thing about that. But that's what you're proving. I'm just saying, as a general rule, you're clearly just proving you're obnoxious to facts. You just couldn't care less. And you're great defenders of science. No, you're defenders of a religion. All right. So he quotes me, bounce back is a pretty dramatic event, the most aggressive collision you can have. Yes. Okay, indeed. Change in direction is a larger change in motion. So it's really just a change in direction. So let's not be silly and say it's somehow more energy. Something goes in this way and it comes out that way. Man, not a big deal. Something goes in this way, it comes out that way. Not a big deal. And we're saying the U-turn is somehow special. Well, it's really not. It's just a change in direction. And the whole argument is changing direction is pretty much for free. It happens all the time. Directions change and nothing else changes. Okay. Then just stopping. So more force is needed. So that's your logic. I've demonstrated over and over again that's not how the real world works. So again, I'll do their silly thing and show you how silly it is. Alright, you have to stop the object and make it move in the opposite direction. Yes, like a rubber band, or a trampoline, or 400 million other things that do this event of elastically catching something and throwing it back, a spring. Alright, so I'll do another illustration of the simple concept and their ridiculous theory of how reality works, where if a ball bearing is bouncing on an anvil, and you only put in 100 momentums and it just keeps bouncing because the spring of gravity keeps catching it and throwing it back, right? That it puts 2,000 times the energy, or whatever amount you want to say, into the anvil. And the anvil moves. Okay, because the earth moves. Yeah, that's their theory. So 1,000 times the energy, or at least they say 10 times. 10 times the energy goes into the earth than the ball bearing actually had. They believe that. They believe you could build an engine that would work that way. I just swing a pendulum into the back of it and it just keeps going and going and going. Anyway. Alright, so let's illustrate. Get rid of this and get rid of that. So what if you had balloons or something? You know, I think that would be a way of illustrating it. So I have a balloon, all right, and we have something that's going to push into it, okay, so just some sort of pusher that's going to move into it. And what do we see that actually happens is the balloon deforms, okay, so it changes its shape, all right, and the pressure increases when the object hits, right? And so now there's more pressure in the balloon. Now two things can happen. If the balloon is light and it will just push on the object because the object's heavier, and the balloon will fly off and the object will pretty much just stay here. So the balloon will be over here, the object will be here, and the balloon does the moving because all the atoms of the balloon can move. But let's say I stop the balloon from moving. So it can't move. There's a brick wall here. Well, then the balloon has this pressure in it. And what's going to happen? Well, the balloon can't move. So the pressure is maintained. And the pressure does what to the little impediment? It shoots it out like a tennis ball bouncing off a wall, right? So there is no scenario where the balloon pushes into this surface with 2x the force. All right. And this actually moves the whole Earth. So the whole Earth is here, and the whole Earth moves. And it reflects. So their theory is, this is their theory. So don't, I'm not misstating it at all. This goes in with 100 momentum. Their theory is that it bounces back with 100, and the wall moves, the Earth turns with 200. That's their theory. And I'm saying, of course, it's absolute nonsense. Both events can't happen. You can't move the object and get a 100% reflection. You can't do that. The pressure is all you have. Just like us going into the Earth. We create a pressure in the Earth, and the whole Earth isn't going to move. Okay? It's not. It's going to absorb your pressure, increase the local pressure, and then the local pressure is going to push you back out, and that's the end of it. It's gone. The increase in pressure is created by you. When this thing hits here, this goes high. The pressure goes up. And all you're going to do is wait for it to come back down again and push you out this way. That's all that's going to happen. And it just depends on whether it has time to do that, or it's going to create heat or deformation or all the other crap that can happen. But so I'm just giving you an elastic example where the pressure is maintained, like a spring. The pressure is maintained. If the surface doesn't move, the pressure stays in the spring, and the only place it can go is that way. There's no other resolution. So it's obvious that no, 100 goes in and the 100 just makes a U-turn and comes back out again. And that's all that's happening when something bounces off of another surface. It's clearly just saying, the surface is saying, I reject your motion. My atoms will not change their position. There's too many of them. They won't change. If they all don't change, none of them are changing. And we have to reject your pressure. So you can increase the pressure on the surface. The surface can say, yes, I'll move. Or the surface is saying, no, I'm not moving, and fuck you. You have to move. Those are the only two options. So if you have some other diagram to draw, if you have some other explanation to explain how exactly you can increase the pressure, and now you have enough energy to move both the Earth and the object. I mean, it's 100 turned into 300. Do you get it? They're saying that I put 100 in of pressure, and I get 300 units of pressure out. 200 into the Earth, 100 back the other way. And these obnoxious, arrogant assholes say, it's obvious that's what happens. It's obvious. No, it's not obvious. And certainly it's not anywhere in the evidence. Ugh, just awful arguments. Alright, so continuing. What does this mean in a collision where a lighter object hits a heavier object and bounces back? So I just explained. What it means is the energy was rejected because all the atoms of the object have to move, or none of them. There's no other options in elastic circumstances. So unless you're going to break the surface, dent it, do some permanent damage to the surface, all surfaces are essentially elastic because all the electrons on the surface are always elastic. So the surface essentially makes the decision. The surface tells the truth. It says this is not working and it rejects it, or it says this is working and we're all going to move. But that's what happens. There's a decision made by the physics that says the object's going to move or it's not. But it can do both. The object can move a little and the bounce back can be feeble. And that we've all experienced, I think. I think you idiots would agree that if I just put As a kid, I used to do this kind of stuff. You put a board up and you throw a ball at it. And yeah, you don't quite get back much because the board moves a little and vibrates, and it doesn't work very well. All right, Newton's third law says that the heavier object will gain the momentum. So this is a lie. So let's just understand. This is not Newton's third law. Newton's third law says equal and opposite. There's nothing equal and opposite about 100 going in, 200 staying in, somehow magically, and another 100 bouncing back. That's not Newton's third law. It's just a lie. Newton's third law doesn't say anything about subtractions. It doesn't say anything about that nonsense, so it's all a frickin' lie. Okay, Newton's third law says that the heavier object will gain the momentum, the lighter object. So we're saying the heavier object gains twice the momentum. That's the theory, shithead. So you're lying some more. Had initially plus an equal amount to the bounce back. Yes, exactly. That's not Newton's law. So again, you can say that. He says equal and opposite reactions. He didn't say, well, you subtract the reactions. He said equal and opposite. This way is equal to that way. So come on, you're being overtly obnoxious to the text. Nobody interprets Newton's law this retarded way. They can understand equal and opposite. Oh, God. I mean, how could you be so scummy as to lie about the third law? That's the one that's the most, I mean, it's so clear in terms of what it's saying. You know, the explosion, yes. Half of it goes this way, half goes that way, yes. I mean, come on. You don't think Newton understood that? Oh, amazing. What a pile of pus you are. All right, anyway, and plus and equal to the bounce, but in the opposite direction. So again, Newton does not say 200 go into the wall and 100 bounces back. That is not Newton's argument. It's clearly saying the same amount has to go both ways. And he's really talking about explosions, frankly. And what he's saying is that if I'm going to change by an equal and opposite. The change is going to be equal and opposite. That is more than 100% the initial momentum the lighter object had. And again, that's free energy, frankly. It's nonsense. It's silly. I can't believe I have to have this argument with literate people that they actually say, yes, I'm going to defend this Holy Ghost nonsense of free energy, free momentum. In other words, the heavier object first stops the lighter object and gains its momentum. So how can it do that? You're saying the heavier object gains momentum and yet it doesn't move. And then you say, well, but it's because it's attached to the whole Earth and the whole Earth moved. So I have to prove the whole Earth didn't move? Yeah, I mean, your people are just such pieces of shit. Then it pushes the lighter object back. So after it moves and it's used the energy to move, it's going to push back too. So that's the 300. It's bad enough they put 200 into the wall. Now they're going to put another 100 going the other way. Gaining the same amount in the opposite direction. So just ridiculous. Because we all know it doesn't work that way. I know it, and I think you know it, that if I take a little cart and put it on a wheels, and I throw a ball at it, the more the cart moves, the less the ball's coming back. I think you know that. I certainly know it. And I think you know it too. That's what's going to happen. The less the cart moves, the more the ball's coming back. The more the cart moves, the less the ball's coming back. That's the truth. And you're just a pathetic defender of shit. And a coward, of course, and all that kind of stuff. End user 99. I have to stay anonymous and hidden because I'm a special agent. Shit. Yeah, trying to destroy civilization by implying that you're everybody's an imbecile. It's just a sad truth that there are no special agents trying to prove the Earth is covered with imbeciles. The Earth is actually covered with imbeciles. Damn. The one time I wanted a conspiracy theory to be true. But no special agents trying to fool us. No. The planet is covered with balls of suck. Okay, your argument used to be that a bounce is a reflection. There's no used to be. I've always made the same argument. It's ridiculous to think you can increase the amount of momentum because it's energy and you can't make it. You can only transfer it. All right. Reflection, where the reflected object just keeps the momentum by itself and doesn't use it to push the other object, but now you're contradicting yourself. Well, that's another lie. That's just such a fucking lie. I'm just going to block you. Fuck you. I did not do that, you fucking piece of shit. God damn it. They can't do anything honest. So again, Newton's third law does not say, well, this moves with 200, and that moves with 300, and that's an equal and opposite reaction. No. 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 I mean, to think Newton was as dumb as you people, I mean, just amazing. Anyway. Okay, so this is the squared seconds thing again. It's just so ridiculous, because I already pointed out, probably in the very video this asshole is responding to, that, yes, clearly the distance is what's quadratically increasing, not the time. So you can use the time squared to reflect the fact that the distance is quadratically increases. So you can say that d equals the time squared. But the time isn't squaring. The time isn't getting quadratically bigger. So that's just a little bit of a gimmick. I'm just saying you're blaming the wrong thing for being squareable. I'm saying there are no squared units of time, there's squared units of distance, you know, where you could quadratically increase something. Oh, brother. So let's just use this as an excuse to go over the gravity argument. And again, this is where they need to draw their counter theory. They need to explain how it actually works, because that's the only way I can see how they're being at all logical. So we have a simple circumstance. I drop something 1 unit of distance, okay, and it hits the ground. And then I have something I drop 4 units of distance. Same thing. Let's just use the same weight. It doesn't matter for this example. All right, so we know this, okay, is going to be the same as this. All right, and we know in 1 second, if we used 1 second as the standard for the time, that in gravity on surface of Earth average, this will be 4.9 units of distance. That's how far it'll fall. This will be 4.9 units of distance. That's how far it'll fall in 1 unit of time. So let's just do 1t, because we know it's 1 unit, so it's 1 second. 1t, okay? Then this whole thing, because of the increase in velocity, because it's going 9.8 now, so it had 0 velocity here. It now has 9.8 in 1 unit of time. So all of that is irrefutable, let's just say. Those are irrefutable facts. Let's say that there's no possibility somebody could disagree that if I put the surface here, okay, that I'm going to get the same impact here that I'm going to get here. Same mass falling the same distance in the same time. No way around it. Okay. So I have 1 unit of energy. That's all I have, right? It's one event. We'll say it's 1 unit of time, 1 unit of energy. Okay, so now what? Now this next thing is going to happen in 1 unit of time. Now, the gravity's a time-dependent force. We know that this velocity is only going to be 19.6, so it only got 1 unit of velocity. So that's consistent. 1 unit of time, 1 unit of velocity. Right? Makes perfectly good sense. Okay. But it is 3 units of distance. Now their theory is that somehow this gave the object 3 units of energy. Okay. So even though it only got 1 unit of velocity added, and even though it's only 1 second, somehow it's 3 units of energy. Now, the argument is how could that possibly be true? That's essentially saying I put 1 pound on the scale, it reads 1 pound. Then I put another pound on the next to it on the scale, now it reads 2 pounds, but I really have 4 times the energy. The actions are exactly the same. The gravitational force is exactly the same in these two units. How could one of them be 1 unit of energy, the same force, all right? Same force here, and it's 3 units of energy. The simple argument is it can't do that. That is absolute nonsense. It's only 2 units of time to drop the 4 units of distance. The distance is a consequence of the acquisition of velocity. It isn't the acquisition of force, 4 units of force. It only got 2 units of force. It's only 2 units of velocity. Yes, it went 4 units of distance in the sense of the 4.9, because these 2 units were essentially for free. I mean, once it's going 9.8, you know that in the next second, it's going to travel this 9.8 for free. So this is all you got. This is essentially the same as this. All you got was 4.9 of extra distance, because this you got for free because you're going 9.8. So you're going 9.8. Then in the next second, you're going to travel this for free, no energy required. And this is the only thing you're adding, is another unit of 4.9. You'll gain another 9.8, and it's going to be the same unit of time. So where's the flaw in my reasoning to argue there's no place to gain any extra energy? It's 1 unit here, 1 unit here, 2 units of energy. That's all. Twice the energy. Twice the velocity, twice the energy. Twice the force, twice the velocity. Newton said clearly. All right, so the other way you can illustrate this. Pause. All right, so back to the... So here we have a gravitational body, okay, something massive, and it's producing gravity. And we're just going to do a flyby. We have a satellite going some velocity, okay, and I can just change the velocity. And it's going to have a trajectory. Oh, isn't that interesting? Yeah, I lost a little bit of it. All right, that's a little better. So the relevant distance is, say, this. This is the gravitational field, whatever you want to say, right? This part is where there's an amount of gravity is going to be affecting an object, okay, based on its transition through this field, okay. And the obvious argument is the faster you go through the field, the less the gravity is going to bend you, because you're not in it, because it's a force that's time dependent. This force, okay, coming at you or pushing you or pulling you, however you want to think about it. You want to think it's a pulling force? Go ahead. It's wrong and stupid, but you know, it's not going to change the argument any. And the simple truth is the faster you go through this differential in force, or whatever you want to call it, the fact is the less it can affect you. Just a fact, because it's a time-dependent force. So it's just the same thing as making the 9.8 meters per second, right? It's the same argument that this is time-dependent. The longer you're in this distance, right, the more gravitational force is going to affect you. And the less time you're in this distance, okay, the less gravitational force is going to affect you. And it's clearly illustrated that it's completely time dependent, because the faster I go, the straighter the line. The slower I go, the more likely I am to be pulled into the gravitational force to bend me more and more. So the amount of bending in my direction is going to be completely decided by how long I traverse that distance. The more time I take to traverse the distance, the more force I will collect, and the less time I'm in the distance, the less force I'm going to collect. Proving, again, just demonstrating what's already in the statement 9.8 meters per second is already proving it's a time-dependent force. It's saying it overtly, and these physical examples demonstrate it's a time-dependent force. You can't collect force except in units of time of exposure, just like I can't collect a suntan, okay, based on how far I walk or where I walk. It's how long I'm in the sun is all the thing that's going to matter. How long was you exposed to a certain amount of radiation coming from the sun? That will decide. My position is irrelevant. Where I how fast I decide to walk, whatever I decide to do is not going to change it, because the exposure is just about time. It's not about moving. It's not about any of this. And the simple truth is, it's not about any of this nonsense about some sort of distance you traveled. It's about how long were you being exposed to some differential in force that existed in the space. However you want to describe the bent geodesic. How long were you exposed to the power of the bent geodesic? And that'll decide how much you're bent. And it's so clear and so obvious. So draw me your picture. You explain to me what's really bending the slower object. Why does the slower object move into the earth and the faster object doesn't? Except for the fact that it's a time-dependent force, and it says it right there, 9.8 meters per 1 second. I mean, how can you screw this up? How can you screw this up? All right, just because it's going to be relevant to his comment, we might as well do this thing too. So understand, this is how gravity works. This is what Galileo observed. All right. So when you drop an object, you end up with this 1, 3, and then it's going to be 5, 7, 9, 11. It's always going to be an odd number forever. The increase in the thing. And so all you're adding each second. So these are all single seconds. So this is second number 2. This is second number 1. And all you're doing is adding 4.9 to the existing velocity. That's it, in distance. So the new distance each time, that is the distance created by the force, is always 4.9. That's all it can add is 4.9. 4.9 here. It'll add 4.9 to the 4 that's going to be provided by the 1 plus the 3. You get it? It just keeps adding up. Okay, so the velocity is creating free motion, okay, in the sense that you don't have to add force. And all you're adding is exactly the same distance from a new force. The new force only adds exactly the same extra distance. And so the trick is you're going half your speed here. Critical thing to understand. All right, so it's not linear. It's not, half isn't in the middle. So you have to be careful when you do an average, because it's not averaging. Okay, you're going half your speed at only 1/4 of the distance you travel. So this rule always holds of this 1, 3. Yes, it's 1, 3, 5, 7, 9, but all you have to know is the 1, 3 part. That's the ratio. The 3 to 5, the 5 to 7, it's all the same ratio. So what the point is that 1 to 3 is telling you the truth. And the fact is if you do this on a linear surface, you'll get the same result. You roll a ball on a surface, it's going to end up going half its speed 3/4 of the way down the track. It's going to go half its speed here. Screaming proof, okay, that gravity is controlling the friction. Clearly a huge indication that, oh, it's duplicating this silly thing gravity does, where half the speed is in some weird place. So obviously it's not where it should be here in the middle. It's in this place over here, indicating that it's not linear. All right. That you're not losing the same amount of energy per inch. Okay, it's just a screaming proof of that circumstance. So it always has to be understood that this ratio exists, and this is what a constant force does when it gives a velocity that's unimpeded. So left to its own devices, let's just say. Now, that gives something an acceleration to start with. In gravity, I can't use their formula because it's distance-based. And now I'm going to go through the distance much faster than their calculated amount. And so I'm going to gain a lot less force than their calculated amount. So they can't use their formula for any other circumstance than holding something and dropping it. There's no other natural circumstance in the universe where their formula will work, because meteors don't do that. nothing moving into a gravitational field has no motion to start with. So their theory will never calculate correctly any real circumstance. So let's just understand it doesn't even work. Besides the fact that there's the better way to understand why there's a quadratic increase in the distance is because you're just adding the velocities. The acceleration isn't anything special. It's just an additional velocity. And obviously, as you increase the velocity, you increase the amount of distance it moves in a unit of time. But the amount you're adding with the new force is always the same. These people are just so freaking obnoxious. All right, continuing. All right, let's see. The formula for knowing the time when an object hits the ground is, and so he's using the kind of messy version of the formula. So you could just write it as the distance. Okay. Now he's going to calculate the time, but it's really just a distance formula. So you can just rewrite it as the distance is going to be 1/2 the gravitational constant, 9.8 meters per second. Not the small g, 9.8 meters. So 1/2, 9.8, well, that's your 4.9. That's that little unit of distance you get each time in 1 second. 1 second, you always get 4.9 for every single object in the universe falling on Earth surface gravity. That's what you're going to get, 4.9, 4.9, 4.9. Nothing else can happen. So that's why it's 1/2 the gravitational constant times t squared. Because you just square the time because you're quadratically increasing the distance. So you're not squaring the time for some other reason than to reflect the fact that in 1 unit of time you go 3 units and then 5 units and then 7 units of distance. Okay. So so I have a baseball and drop it from 10 meters. Now why wouldn't you drop it from 4.9 meters? Well, why not make it simple? 1 second. So instead, he's making a kind of messy, argument about how far it's going to fall in 10 meters, which is neither 9.8, it's not in a 4.9, and it's not 19.6. Those are going to be the 2 full second units. So he's taken something somewhere near the middle, and you can see 1.42, kind of a weird number. Now that's he says in 10 meters. Now that's again reflecting the fact that you're way short of the 19. So 10 is, if 4.9 is here, right? We can do 4.9 is here. That's 1 second. Okay, he's going to 10, and we know 2 seconds is 19 meters, 19.6. So obviously the 10 is in this kind of not proportional circumstance to reflect the fact that, the second unit of time, the half the speed that's adding, that is half the 4.9, is going to be way up here instead of here. So that the 9.8 you're going to get here, and this falling from the 4.9, okay, I should have drawn that. Okay, falling from the 4.9 to the 10, that difference is, again, 1 to 3. So it's not halfway between 4.9 and 19. It's higher because half the velocity happens in the first quarter of the distance you will be moving in that 4.9. So the 4.9 is doing the same thing the 9.8 is doing, in the sense that it's disproportionate. You're going half your speed when you've only been in 1/4 of the time because of the way it accelerates. All right. And the way it acquires the acceleration as it's moving faster and faster. So anyway, he could have done a simpler example. That's all I'm arguing. I know it empirically, so I don't know. So when did you test this? So where's the experiment? Why don't you just show me the experiment? The ball will hit the ground at 1.4285 seconds. Okay, test it yourself. No, you show me a test. Why should I test it myself? You should have the evidence somewhere. You should be able to link to it. You're giving us the exact numbers. It must have been measured by somebody, right? You're not just calculating this crap, are you? Oh, well, that's terribly unscientific not to do the experiment. All right, so he's just writing the same argument I made in the video. Okay, I clearly said, yeah, you can use an equation where the time is squared. That's not a squared second exactly, because of the fact that the distance is quadratic, not the time. So let's just understand, the time isn't the thing that's fucked up. The distance is the thing fucked up. All right, so and then he says, let's solve for g. And so we know this formula only works in the one special case. One special case. You have to hold something and drop it. It won't work if you're going to calculate a meteor. So if I'm going to calculate a meteor coming into Earth, it's not going to get the right answer because the distances aren't doing the same thing anymore. The same distance isn't happening in the same amount of time. So all of the time numbers are completely screwed up, and you can't use this calculation. You have to use the calculation where you recognize that it's the time that matters, not the distance. The distance is irrelevant. All that matters is how long are you in the gravity, and that'll tell you how much extra energy you're going to get from the gravity. So if I shoot a gun from high in the atmosphere, say a balloon, and I shoot a bullet into the Earth, the bullet will not get the same energy from gravity as if I just dropped the bullet. It won't get the same added energy. So gravity will be almost negligible because the bullet's going so much faster. Okay, that means it's going to be in the gravity a tiny amount of time, and it'll be a negligible amount of gravitational change. The gravity will do little to change its velocity because its velocity is so high, it's going to go through the gravity so quickly, it's barely going to get 4.9 meters. It'll be barely a second in the gravity. It'll barely get 4.9 of extra distance and 9.8 of extra velocity. So it has a velocity, let's say, of 3,000 miles an hour or something, and it's going to gain 9.8. So it'll be 3,000 and 9.8. So it'll be a tiny change. And if I just dropped the bullet, it would have taken it, 7 seconds to hit the ground. It would have gained 7 units of gravity. It would be going 100 miles an hour, 70 miles an hour. Fact. So all of this crap is useless. It's not anything I haven't already acknowledged. It's just an absolute waste of time and doesn't have anything to do with the argument. Your argument is that you collect gravity based on units of distance you travel. And it's overtly in the formula saying, no, it's 9.8 meters of extra force, of extra motion per second. Not per inch, not per foot, not per meter, not per centimeter, not per nanometer, not per any unit of distance. It is 9.8 meters per second of velocity, and it's per 1 second. You get it in units of time. You do not get it in units of distance. It's 4 units of distance. It's only 2 units of time. It's only 2 times the velocity. It's only 2 times the weight. It is not 4 times the energy. That's the argument you have to counter. This crap is not on the subject. You have to prove that something gains its energy by distance alone. And it doesn't matter how fast it moves in through the gravity. It doesn't matter how fast I go across a gravitational field. I will be moved by it exactly the same because it's just about the distance I travel in the field. And that's going to be an absolute impossible thing for you to demonstrate because every single space adventure we've ever conducted isn't using that rule. It is using the rule that it's just about the time. Okay. So, fuck you. Jeez. Junk, garbage, trash comments. Alright, let's just do a refresh, see if there's anything. Might be some new comment, some new and exciting pile of crap. No. Okay. So again, this really should be something where, like I said, they could All of these people saying I'm wrong, you think one of them could draw a fucking picture of how gravity works, how rolling on a surface works, how sliding across thin ice works, but they can't. And really, it's a stalemate in the argument because they're not providing any mechanism for their nonsense. They're not explaining how the hell I create pressure in a object. So again, we'll go back to the ludicrous statement that somehow I can make free momentum, that I can actually bang into something with a certain amount of force or pressure, that the pressure is incurred on the surface, right? The surface has to collect it. The surface says, yes, I'll move the whole object. So the little bend here moves the whole object with twice the momentum that I hit it with. So the whole heavy thing is now moving with more momentum than the little thing had. And I get 100% back. I get my ball back again to just throw back at you. So I could have it on a spring, right? Throws it, catches it, 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 throws it, catches it. You get my point, right? I just put a spring here, okay? A spring device, okay? I cock it once. The ball flies into the surface, it bounces back, moves the spring back again, it throws it back. So I don't have to give it any more energy, theoretically, right? It's a really good bearing, really good spring. Let's just say theoretically it's damn good. It's in a vacuum in space, whatever you want to say, and it just keeps doing that. Okay, right? Because I get 100% back every time. And I just have that on a little slider, so this heavy thing can slide. And so their theory is that every single time the ball bounces off this surface, this moves with 200, this moves with 200, this moves with 200. So it's now 400, and then it's 600, and then it's 800, and then it's 1,000. It just keeps gaining more and more momentum. I keep throwing it. It gets further and further away, so eventually I can't hit it anymore because it gets so far away and it's going so fast. But it's obviously a free energy mechanism, for fuck's sake. There's absolutely no reason why I can't build this thing if your theory is right. There's no reason I can't build this fucking thing and actually just use 100 little feeble momentums. I just put one little push into it and it will shoot 4 tons at 60 miles an hour or something. Because I'll just let it keep doing this. I mean, this is so fucking stupid to have to make these arguments and these assholes. So go ahead, redraw that and explain to me how I can't make that machine. Explain to me why this machine will not work. To make perpetual free energy. Shit. Alright, so I guess we'll call that a video. Yes, okay. Hate this planet. Just hate it here. You people suck. At being honest. Again, you can't even be honest and say, well, yeah, that's a pretty good argument. Yeah, it doesn't make really much sense that I could just keep making, 200 and it's going 400 momentums and 600 momentums and 800 momentums. And all it depends on is how efficiently I can make this machine work. If I can take all the friction out and all that kind of stuff. And yeah, it does sound kind of loopty-doopty. Yeah. Sounds like a big pile of shit. Anyway, so, no point, Bill. Just no point. I mean, I guess in this example, they're going to argue that the Earth moves this way, and then because the spring collects the energy, it's going to also go 200 that way, so the Earth is going to go back that way. But it really doesn't matter because the thing I'm pushing isn't the Earth. So it's still going to keep going. Can't stop the thing from moving. But it's just, it's just so ridiculous that they think you can use energy multiple times in the same moment. No. Energy can bounce over here, and it can go over here, and it can go over here, and it can go over here, but it can't be in all those places at once. No, it can only be in one place at a time. There's just no point talking to these morons. Sadly. That's all there are, is morons. There's nothing else to talk to. Be nice if something else besides a moron would show up, but there aren't anything other than morons. I mean, in all these years, I don't think there's been one convert. You know, there were people who trusted me, so to speak. Okay, they know, hey, Gary's right a lot, so Gary's probably right. So there's a few people who will defend what I'm saying because they know I'm right, blah, 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 blah. But that's just from their personal experience, and so they're sort of fans, you know, so you can't take anything they say too seriously. And then there's the opposition. It's just there's nobody being persuaded. No one. Absolutely zero progress in years of arguing where they concede, oh yeah, it's about the fact, you know, when you slide across the thin ice quickly, it doesn't break because, yeah, you're collecting less gravity. So you can't crush the ice because you're not into gravity as long over the piece of ice. Every inch of ice is feeling less pressure, so the ice doesn't break. They can't concede arguments that simple. Just fucking amazing. Amazingly bad. It's just such a bad statement. But again, the whole world is going to be on fire in 15 days, so who cares? Anyway, till the next time and such and so forth and whatnot.